This week we're looking back at some of our favourite forms of transportation.
There was the time we rode around wheels of steel with a Swedish scooter that's as flat-packed as its furniture.
With the curve folding, we dance with the metal.
Alistair uses a bit more pedal power.
I can feel the device giving me a boost as I cycle.
Only a bit though. But how do the same engineers create this?
No, that is not real. That cannot be real.
Adrienne checks out a pioneering scheme to get electric cars moving around our cities.
We can get the pickup down. Yeah, there we go. Oh yeah, I can see the green light.
And Paul is on his latest railway adventure, trialling a new kind of train in Italy. Scooters. They're lean, nifty, greener than cars, really green if they're electric. But there's one thing about them that could still be greener. The way they're made and what they're made from. This is Still Ride 1. It has one very unusual feature. Its chassis is made from one piece of steel. All the curves, all the lines have been folded like origami, following a design by its creator, Tuve Beyer.
With the curve folding, we dance with the metal.
The reason is not just about aesthetics. See, a typical scooter is assembled in special factories from more than 100 parts, and then it's shipped around the world. But for this bike, all that would need to be sent anywhere is the design.
Because a bike, if you would send a bike in a crate, you're shipping air. You don't want to ship air. Whether you're in Sweden or in England, you'll probably find sheet metal, right? So it's better to send the code rather than to send your final product. That's very, very efficient way to do it, you know? So you want to produce near the end customer.
I've been given permission to fire the laser.
The plan is for locally sourced steel to be laser cut into the flat chassis pattern, and then for robots to bend it into the right shape, like these ones are currently doing for other simpler objects. All in all, there are 15 components, including a saddle that also starts life flat.
And once it's all been folded up, it comes here to be welded. And it looks like this.
While the design is still being perfected, the prototypes are bent manually. The curved folds in particular are hard to get your head around. Stillride has developed its own software to calculate how to get the shapes that they need, with help from a hand-cranked folding machine back at the office, that is. But I know what you're thinking. Without all those bolts and screws and separate supports, can a folded piece of metal be strong enough to ride around on?
If you put a straight fold into a material, it doesn't become that strong, because even if you lock one side of the fold, it can carry on bending like that. But if you put a curved fold into a material, then as you change the shape on one side of the fold, it forces the other side into a particular shape too. And that means if you lock this side into position, the whole structure becomes rigid. The best example I've seen of that is your French fries container, which is pretty flimsy when you're only using the straight folds on the edge, but there are two curved folds on the bottom, and if you engage those, the whole thing locks into place and your chips don't fall out.
The bike that we created now, or the chassis that we've done for the Stillride 1, compared to a competitor bike, it's a tubular frame, a typical scooter. We created a chassis that's even 50 times stronger or more stiff, rigid than the tubular frame.
Stillride has bigger ambitions than just 2 wheels of steel. Parts of larger vehicles could also be made this way, along with the footings for wind turbines that would imitate tree roots. And really, even whole bridges? Well, maybe in sections. One step at a time though. The scooter goes into production later this year and it'll cost €15,000. Okay, from bikes to trains now. And did someone mention trains? Then everyone make way for Mr. Paul Carter.
It's a dream come true.
Choo!
He loves the train.
Loves a train.
In the past, he's been in Italy testing out its modern ticketing system.
What else? Oh yeah, here he is checking out a high-tech solution to leaves on the line.
And he was one of the first to check out the new Cross-London Elizabeth line before it officially opened in 2022.
This station is Paddington, where this train terminates. All change, please. All change. I've always wanted to do that.
So, a show devoted to transport tech would not be complete without Paul Carter on a train.
These might look like any other train, but they're a first for Europe. These trains, being built in the heart of Tuscany, are Europe's first tri-mode trains to enter passenger service, having started running on routes in Italy at the end of 2022. As well as being fitted with a pantograph for overhead power and a standard diesel engine, they're also fitted with a battery pack power unit and can be switched between modes. These trains are being manufactured by Hitachi Rail for Italian rail operator Trenitalia, based on Hitachi Rail's Masaccio platform.
The characteristic is that he can combine during the trip and change this technology during the life, so without any sort of discontinuity and any sort of disruption.
Trenitalia brands their services around different music genres, such as rock, pop or jazz. They've decided to brand their Masaccio trains as blues. Diesel trains are still necessary and are likely to be for some time because of the wide variation in the amount of electrified lines, particularly across Europe. So train manufacturers and railway operators across the world are looking at greener and more efficient ways to power their trains when external electric power isn't available. However, these trains will still rely on diesel power for large parts of some routes. The batteries only have a range of 15 kilometres at present, though they can be recharged while the train is in operation, both in diesel and electric mode. When it's near a station, the batteries power the train completely, cutting emissions and reducing noise. At other times they will use overhead power, or when the line is unelectrified, the diesel engine. However, the batteries will still be able to power other aspects of the train than just propulsion, such as lighting and heating.
So what are some of the challenges with implementing battery technology in trains? Is it weight or is it power consumption?
It's a combination of these two items. So our expert and our designer are continuously working on it. Reduce the weight means also reduce the energy and the consumption, and it's a problem of space, it's a problem of weight. So the evolution of proposal for battery, it's improving this aspect. This is why in terms of weight and size, it's okay, but now it will require test in order before to go on the market.
Despite this, Hitachi claim these new trains will produce 50% less emissions than regular diesel trains.
Currently, we are totally focused on battery solutions. Of course, our research and development is working on it, but in terms of time to market, we are confident and believe that this solution will have a strong success in medium and short time.
Like cars, the direction of travel for trains is towards that of battery power. But unlike cars, trains aren't quite there yet. Now, trains like this specific one are a step in the right direction, but we're still quite a few years out from having fully battery-operated trains. But at least we're on the right track.